Okay, we are going to be looking at panels, just kind of doing a little bit more training here for panel drawing. Now, if you want to go back, you can. We did do a video previously that had a rundown of all the different panel hardware that you're going to see on drawings, talking about things like reveal types, the standard reveal types, full depth, spline reveals, quirk reveals, curve cuts, butt joints, all of those types of things. We also talked about fry riglet reveals in the past video as well, so that might be a good refresher to review that once more before jumping into this one. The last thing that we did mention about that as well is that we also had we talked about two different types of panel attachment methods, one being our standard, which is what we call panel cleat and ceiling cleat. Panel cleat and ceiling cleat are a shop-made attachment method, usually also referred to as a French cleat in other industries, but we call them panel cleats and ceiling cleats. It is just a really thin piece of material that has a lip on it, so that way you can lap the two profiles together to attach your panel either to a wall or to a ceiling. The other method that we did discuss previously as well is the Z-clip method or Z-bar method. That is a bought product that is by this company called Monarch Metals Incorporated. It is referred to as hardware 20, I believe, on our standard list of hardwares. So if you're looking for it there, that's where you can find that. That one actually does have a hardware call because it is a bought item versus the panel cleat and the ceiling cleat. Those are both shop produced hardware, so they do not have a hardware call on the drawings. Just kind of a quick refresher on that. The panels that we're going to be looking at here are kind of like column panels in a way. So as we get into that, let me pull up the drafting schedule and we will take a look at what those look like here. All right, so give me one sec here and I'll get that pulled up. We have reserved these panel drawings for training. These are P1, 2, 4, and 5 for Project Proscenium. That is project number 6434. If you want to dig into that, you can. I would go ahead and sync this job folder to your machine. That way you have easier access to the drawings in this project if you want to follow along. Again, that is project 6434. And we're going to probably start with P1 and take a look at that. Now, little backstory on Proscenium here. I don't have a meeting recording to review here at this point. This project just released at the end of last week, and so I have a meeting scheduled for tomorrow. So for today, what we're going to do is we are going to take a look at these drawings, and we're going to use our company standards for drawing these panels. Doesn't mean that that's how they're going to stay, but what we'll do is we'll go with what we know is standard, and then if it changes, it changes, and we'll just have to do some revising on the later half of the videos here. So starting out, let's look at P1. P1 is in the lower lobby of the level 1 area. It's room number 125B. It's also going to be on this ARC reference here. Looks like page A600, views 2 and 5. If you want to pull those up, you may, and I'll go ahead and pull those up on the side here as well. So we can start digging into that. So going to Project Proscenium 6434, going into Drawings, and Architecturals here, where we're going to begin. So P1, page A600 appears to be the first drawing that we are given as a reference. So let's pull that up. Because we do know this is on level 1, I'm also going to pull up the level 1 floor plan here too, or partition plan or construction plan. It depends on the architect and how they label their drawings, but we'll go ahead and pull that up as well. And then we can start digging into what these drawings look like. Okay, so on level 1 of Proscenium, P1 is located on the plan west side of the building. So we're looking at the floor plan. We need to zoom over to here, and you can kind of see where these P1 calls are pointing to. See, there is one over here, and there's one over here too. So there's a panel that's on this side of the wall over here, and then we got one over here on the south side of that lobby as well. All right, now, one cool thing about this is there are blow-up views of this lobby. As you can see, these bold dashed lines that kind of go around, you can go into here and kind of take a look at what these look like. So you want to go here to look at this one first. This is page A515, view number 2. So let's go back to the drawing folder and find that. All right, view number 2. Here we go. So this one is not highlighted, but when you compare it to what's going on the floor plan, you can kind of see there's a column right here and a glass wall here and a glass wall over here. Now I'm going to use those to kind of help figure out where P1 is on that enlarged view. So again, we're looking at view 2. I can see that column that's right there. And there's the glass wall, there's a glass wall there. So if I was looking at this correctly, it looks like P1 would be this panel here. And I can kind of highlight that real quick so you can kind of show what that looks like. Sorry, I'm just going to do this real quick here. Got it. Okay, so that's kind of the extent of what we're looking at here. There is a slight gap between the panel and the wall. Kind of see that right here. And what we'll do here is we will draw this here as a veneer panel here. And then let's go ahead and see if we can find the blow-up view of the other panel in the lobby. So going back to our construction plan, zoom out a little bit. And we're going to see over here on this side, there is another bold line that goes around the room. And if you follow that bold line, eventually you will find a call out that takes you to the page that it's going to. That's page A770, view number 1. A770 and view number 1. All right, so view 1 is in the bottom right corner of that page. You can see there's the staircase that we were seeing in our construction plan here. And we know that our P1 panel is on this column here. So let's go back to that blow-up view on 770. And let's see if we can find that, that panel. So looks like our panel is here. It is slightly cut off in this view. No big deal, but it gives us kind of a reference as to what we're looking at. All right, so there we go. That's kind of representing part of the panel. You can kind of see again, just like the other one, there's a small gap between the panel and the wall here. And then on top of that, you can also see that the panel is cut off here. And so when we look back at the construction plan of the building, you can kind of see exactly where that cutoff is happening. So right where this bold line stops, that's where the panel is not being shown. Again, kind of looking back at that, we're missing part of that panel here. So we are given a partial view, which is kind of enough to get us going. There's also a blow-up view here on top of that blow-up view on page A771. Let's go ahead and see what that view 6 looks like on that page so we can kind of see what's happening there. Okay, view 6. They show that there is a 1-inch gap between the, this is a wall and a wall cap here, and then our panel here. If we go to the elevation view, I'll show you what that looks like here. Okay, so there's that 1-inch gap right there. Kind of see that right there. There's that wall cap that we're seeing there in the plan view. And then there's our panels there. So going back to there, wall cap here, 1-inch gap here, panels there. So all this really is trying to tell us is that we do have a 1-inch gap between the panel and the wall to the right of that panel. All right, so let's go back to our plan view once more. And we know we got 2 sets of panels, one here, one here. We're going to go back to our elevation view, and we're going to take a look at what we have going on. So on page A600, we know that we have panel drawings on page 2 and 5, according to our drafting schedule here. Again, that's 2 and 5 on A600. So 2 is the smaller panel here, and that relates to this panel right here. It's kind of goofy. It shows it a little bit wider here. I wonder if something's happening. Maybe part of it's cut off, or maybe it's changed slightly in the way this is drawn. But we are showing a narrow panel here. We're showing a wider panel here. So I might have to ask about that one just to confirm if the panel actually does go all the way to the window wall, or if it goes just to here. So we're going to take a look at that in just a moment. Now let's take a look at the other panel that's in that lobby and just see what's going on with that side. This side here is right here. This is in the south part of that lower level lobby. You can kind of see what's happening here. We got P1. We're going to go back to our elevation view, and this would be that P1 drawing that we're seeing right there. Okay, and that would be as if we were standing in the lobby here, looking this way at that panel. All right, so now that we've located the panels and we've located the plan views for those panels and any enlarged plan views off of those, we're going to take a look at a couple other things. So as you can see right here, these panels are drawn without reveals. That is pretty common. I wouldn't say all the time, but it is pretty common with architecturals is that you don't always see the reveals located on their drawings. So sometimes you have to use a little bit of either creative liberty, or you have to kind of use, I guess, an educated guess as to where those reveals should go. Most of the time when we talk about reveals, what those are for is to break these panels up. So that way there's 2 things we got to look at. One, can we get the material in that size that the panel is drawn at? So for instance, if you have laminate or veneer, you do want to make sure that you can actually get that sheet of laminate or veneer in the size that they are asking you to draw the panel in. If you were to, for instance, have a sheet of veneer that comes in 48 by 96 inches, you can't have a panel that is 48 by 120 without having a weird seam in it. So, and same thing with laminate too. We try to do our best to make sure that like the material itself matches up with the size of the panel that we are allowed to, well, what size we're allowed to make the panel in. It's mostly determined by the yield or the what the material is available in. Okay, so that's one aspect of what we look at when we determine reveal locations. The other aspect that we're going to look at is also the ability to get the panels in the building and through the building. So we are in level 1 here. In level 1, usually there's going to be exterior entrances that go into the building. So that second aspect really probably isn't much of a concern, but it's something to keep in mind because anytime that you're dealing with a piece of furniture or a panel, you want to make sure that you can get it through the building, through any elevators that has to go through, and into the space that it needs to be installed in. And so typically with panels, you do want to try to draw them no more than 48 by 96 inches. Sometimes you will have panels that are longer or wider, but not always the case. But most times you can get them in 48 by 96 at max size. So I try to shoot for that. Now, if I'm looking at the panels that we have here today, you can clearly see that the width is not an issue. The width here, really, we're dealing with panels that are most likely going to be like 2, maybe 3 feet wide at the most. So no big deal. If you are dealing with an entire wall of panels, let's say like all these GL4 calls were panels, just for example, these aren't actually ours, but if these were our panels, we would want to make sure that we could put reveals in between these panels that make sense with the finish of those panels. So just making sure that you don't make the panels too big to the point where you can't get them in the building and you can't buy the material in that size. One thing we're going to do here is we're going to look at where the reveal should go, and then we're going to talk about what the reveal types should look like. So looking at these panels first, we have this kind of weirdly shaped, almost like an L-shaped panel happening here. So over on the left-hand side, we're given a dimension that says 10 foot 4.5, going from the floor to the center of this metal mullion. Metal mullion being the metal channel that goes between two glass panes in a wall, typically. Usually for outside walls, you'll see glass walls that have metal tracks at the top and bottom. That's what that is. So they're giving us a dimension to the center of that, which helps a little bit. It gives us some information, but not quite enough to really know what we need to do here. So what I'm going to do is I'm going to find out what the scale factor of this drawing is. We're going to go 3/8 equals a foot. So I need to go over to the left-hand side of my Bluebeam here, pull up the scale factor, make sure I'm using the correct one. And then we're going to go and make sure my precision is set to a 16th. Usually I try to go to about there. Gives you a pretty good feeling about like what size these panels are without rounding it, because you don't want to round it as much as possible. Okay, and so what we're going to do with that information now is we're going to go from the floor up to the underside of where the panel makes that L shape. Looks like we're given a panel that is about 10 foot 3. Now I will round this down to 10 foot 3 because I think the 16th is just an extra bit that doesn't really make sense. So with that being said, if we are at 10 foot 3, we're at 123 inches tall. Going back to what we talked about before, I do like to try to make sure that my panels don't exceed 96 inches in height and 48 inches in width. And so what I'm going to do is I'm going to put a reveal right here, right in line with the bottom of that mullion and right where the panels are notching here. Okay, so we'll put a reveal there. And that still makes it a little bit on the longer side. So what I would like to do even further is break this up by putting a reveal in the dead center of these two panels. So these blue lines are representing where the reveals are going to be placed. And I still need to look at breaking up this taller portion here because I have a, this is still pretty tall. We're dealing with a panel that's it's not clearly called out, but we're talking about maybe 12.5 feet tall roughly. And so we do still need to break this panel up as well. We can't just leave it as it is. What I would suggest we might want to do, there's two things we can do. We can either break the panel right in the middle like this. Now, the one thing I would say about that is that aesthetically, maybe it looks good because the panels are equal in height. But the one thing you're going to see if you were to break that up just like this is that now you have a line here, it has a zigzag, and there's a line there. And so maybe to keep things consistent, it might be worth our time to try to put this reveal here so that it lines up with the bottom of the mullion like this reveal here. Now this is kind of just me aesthetically trying to put this together because we're not given a lot of direction from the architect here. If you wanted to at this point, what you could do is you could call up the project manager, which this is Rod Carrero's job. You could always give him a call or send him an email or a message with a screenshot of what you're dealing with here and just have him confirm if the reveals are in a good place or in a place that makes sense to him. I would say that's a good place to kind of get the project manager involved to make sure things look right. I am going to run with this method of thinking here for right now. So we'll do a reveal here, a reveal in between the two, between the floor and the bottom of that reveal. And then we'll do a reveal here in line with the bottom of that mullion, so that way we don't have a 12.5 foot tall panel here. Now, one last thing to think about too is when you have panels on a wall, going back to our video that we talked about the panel hardware, a panel cleat or a Z-clip will need something called lift-off space. Lift-off space is a gap that is shown at the top of the panel, and what it is to allow the panel to be cleated on properly. So when you install a panel on cleats, it has to lift up, slide back, and then drop down. When you have that, you will have a small gap at the top. Panel cleats, typically that gap is as small as 3/4 of an inch. That is our standard there. Anything less than that, those panel cleats will not work. If you were using those Z-clips or Z-bar by Monarch Metals Incorporated, you can go down to a 1/2 inch up there between the ceiling and the top of your panel. That's enough for that to be able to do that same motion of lift up, push back, drop down. Now, if you want an example of that, you can kind of look at a panel drawing, or back in that panel hardware video, we did discuss that. When we get to our section views, we'll show that a little bit more too, so we'll kind of explain that a little better there. So this wall, we've got a pretty good understanding of what these panels need to look like. Let's go back to the other wall and just take a look at that as well. Okay, so now these panels are both in the same room. And so with that being said, it might make sense to put the reveals in the same exact locations, pending these panels are exactly the same height from floor to ceiling. I think we might want to do that. That way everything looks clean and consistent across the room. So if I go back up to this panel drawing up here, and I copy these reveals, what I'm going to do is paste them into this area down here. And we are going to line them up best to our ability. Now this one's only about 3/4 down from the top, so we're going to say that's about there. And if you look, you can kind of see that these actually do line up pretty well with what's happening in the room. There are some areas like here that kind of don't line up with things right now, but when you look at it as in you're looking at the entire room as a finished product, having these reveals lined up with each other kind of does make a lot of sense. Otherwise, they're going to look all over the place, like kind of scatterbrained a little bit. So I'm going to leave these like that. Okay, so you can kind of see those reveals there now too. Reveals there, reveals here. Okay, so I'm going to recap a little bit back to when we talked about panel hardware. So reveals, on-site standard for panel to panel reveals, as in I have a panel meeting another panel. We're going to use what's called a 1/4 inch spline reveal. So there will be a 1/4 inch gap between the panels, and there's going to be a spline that gets machined into the side of one panel and the side of the panel attaching to it. And that spline is going to be finished with the same material as the outside of the panel. So that way everything matches up and it looks nice and consistent. So we're going to look at that when we draw our section view. I wanted to bring it up now because there are other types of reveals out there, but on-site standard between panel to panel will be a 1/4 inch spline reveal. When you get to the very top here, this 3/4 inch reveal that we've been talking about, this will be a 3/4 inch full depth reveal. Full depth reveal, all that is you have a block of material that sits behind the panel, finished with the same material as the panel face. And so everything looks like it's all veneer, but there will be a small gap up there at the top. And we'll see that in our section view when we go to draw that later. Okay, so initial overview for P1. We can go back to our plan view. We've discussed reveal locations. We've also discussed locations of where these live in the drawings from the architect. One area that we do need to question is why this length here is different than, or I guess the width here is different than what's shown in the elevation view from the architect. But we can do that at a later time. Normally, I would suggest at this point, I would put together a list of questions that I have for the project manager and try to ask them all in one email if possible, or one phone call. That way you're not having to call them or email them several times. You can knock them all out here at the same time. So at this point, what I would be doing is rounding up what questions I might have. In our case, if the project manager was here, they're out sick today. If the project manager was here, what I would do is give them a call, go over that discrepancy that we see here, where the width is different here versus what's going on in this elevation view here. And then I would also bring up the reveal locations and try to confirm if these are looking to be in the correct locations for what is kind of expected for the drawing. So a couple things to note there. These are veneer panels too, by the way. And when you have veneer, you always want to have a grain direction attached to those drawings. So in our case, I am going to assume the grain direction is running vertically. It's not clearly stated, and if you look at the hatching they have on their drawing, it doesn't really do a good job of it because the way they show it, it's almost like the grain is going like that. When in all reality, most times panels are not going to look like that. They're most likely going to be vertical here. So I'm going to run with that method of thinking, and we'll assume all these are vertical grain veneer. All right, and yeah, everything's VN1 it looks like, or WDV01 according to the architect call. So we're going to have one consistent material across the entire drawing, which is great. Makes things a little bit less complicated for us. And you'll see that as we get into drawing panels, there's a lot less notes and complex hardware and different things you have to take note of. Like cabinets, there is so many different hinges and slides and locks and all kinds of hardware. Panels are a little bit more laid back. I mean, they are complicated for sure, but they have a lot less little bits of information to keep track of. So let's go ahead and begin our drawing here. So I'm going to go ahead and get an AutoCAD file open. I need to go to the job folder, drawings, prelim project, and I'm going to pull up the drafting template for this job. Okay, now AutoCAD's taking its time here. I guess while it's loading up, oh, there it goes. Never mind. I was going to say we could look more at the panels, but looks like it'll be up and running in just a moment here. Come on, AutoCAD. You got this. Okay, perfect. So just like what we've been doing, what I'm going to do is split screen our AutoCAD file. Oh, I guess it's still loading. Split screen our AutoCAD file with our Bluebeam drawing set. And I'm also going to pull up our drafting schedule over here too. Because the first thing we always want to do with a drawing, once we've opened the template, is we want to go ahead and, one, fill out the title block on our template, but then we also want to save as and make sure we don't save over the template itself, because this is a community template for the entire drafting team to work off of, so we don't want to claim it as our own and save it as our drawing here, because then everybody's going to have to delete it every time, so we don't want to do that. What we're going to do here is we're going to write in that these are veneer panels, is our description. We're going to write in here, level 1, lower lobby 125B as the locating area. Okay, and then we need to put in our packet number, which is 46399. And our sub number here, sub number again, if you scroll over to the left-hand side of your schedule, it is right next to your packet number, 003, just like that. Okay, drawn by, we're going to change those out to be your initials. And then that is all we really need at this time. Now, because we are going to be making all of these panels out of Veneer 1 or VN1, if we go over to the job-specific finish calls, we should be able to locate VN1 in here. Looks like it's right here. I'm going to copy this over using a base point of my grid and pasting it right there, just like that. Okay, then the other thing I will do, usually save this for last, is fill out the general notes though. So because there's a lot less to worry about with panels, it's kind of easy to fill out ahead of time. I think I'm just going to copy this one here. This is all walls. Floors and in-wall blocking are by others. We're going to need that note. Let's one sec here. Okay, yeah, we're going to need this note here. And then because we're not dealing with any cabinets, we can just ignore this column here. We don't have any banquettes or benches on this drawing here, so that note goes away. No die walls that we're building as a company, so we can ignore that area. There's actually no base trim under these panels, which is kind of surprising. Usually panels do have some base trim under them. So anyway, with that being said, there's no notes to copy from there. No metal shop drawings, so no weld notes are going to be required. And also no poles since we are not dealing with cabinet doors. So those notes don't apply to this drawing either. So you're probably thinking to yourself, wow, I don't have anything in my finishes or my general notes. But really, when you're dealing with panels, that's really about pretty realistic as far as what you're used to seeing. So panels have a lot less of information to apply to them, but that doesn't mean that they aren't just as complicated as cabinets. To draw them, you still have to be able to kind of take what's in the architecturals and visualize and then put together a set of drawings, just like you would for any other drawing, like a cabinet drawing. So before we move on, what we're going to do is we're going to save as, and we're going to make a copy of this in the prelim project folder. Let's make sure that we're in the correct job. So we're in Proscenium, Drawings, Prelim Project. And we need to label this correctly here. So this is P1, PKT 46399. And then I'm going to copy in my description from over here. And I'm going to write at the end version 1.0, just like that. Go ahead and hit save there. So we are saving that right to the prelim project folder, and now we are working in our own separate CAD file and not the template. All right. Last thing before we go into our model space, always remember to change your tab at the bottom to read your print reference rather than the default FX.0. We'll go P1.0 there to match what's going on in our drafting schedule here. All right, let's go over to model now. Let's save it one more time. Over to our model space, and we're going to start working away at what we have here. So for these panels, it may be easier for us to start with our elevation views and work our way backwards. One thing you can also do as well, if it helps you at all, is if the project has a floor plan CAD file, you are more than welcome to steal that out of here. Doesn't look like I've actually made one just yet. And so with that being said, we won't be able to steal that exactly, but I'll show you how to do a PDF import so that way you can actually bring in a portion of that floor plan for your drawing here. We'll talk about that in a little bit. We're going to focus on the elevation views first. and then work our way into the plan view after that. So start by pulling up our AutoCAD, or sorry, our Bluebeam over here. All right, and we're going to look at the area up here first. So the wider set of panels here. All right, now I am going to plan on moving my elevation view into here later. So what I'm going to do is actually just start off to the side over here somewhere in the blank space and work my way around. All right, so a couple things to take note of. We know from floor to ceiling, it looks like how tall the ceiling is. If you don't see that here, another area that you can look to see if it tells you the ceiling height would be on the reflected ceiling plan. So if you're dealing with a, let's see, proscenium drawings, architecturals, and reflected ceiling plan for level 1. All right. If you are looking for your ceiling height, one really good place to check is your reflected ceiling plan. More times than not, it is going to be noted here, and it's going to tell you exactly how tall that ceiling is at or above finished floor. So AFF standing for above finished floor. The ceiling here is 15 feet tall. All right, so let's go back to our drawing here, and we'll just check the math and make sure, because that kind of seems a little off. Not sure if that's true. Let me check. So 10 times 12 plus 4.5. And then we have 96 for the 8 inches, or 8 feet plus 3 inches there, plus 48 plus 4.5. So 276 inches tall, which is actually 23 feet tall from floor to ceiling. So it might be another thing to at least question to the project manager if you're seeing something like that. I'm guessing that probably what is most likely happening here is that they are probably taking the finished floor from the top of the stairs to the ceiling here. I'm going to guess that that is probably 15 feet there, and we can even maybe check it to see. Not that it really matters to our drawing, but I just wanted to kind of rule out any discrepancies we're seeing there. So really it is 15 feet from 15 foot plus a 16th of an inch. So I'm just going to say 15 feet from the top of the stairs to the ceiling. So that makes more sense. Because right here, what we were seeing is about 23 feet from the floor to the ceiling here. This is kind of like a sunken lobby. If you go back to the floor plan, you can kind of see that. This is level 1 here. This is what they call the lower lobby. So this is kind of almost like a basement level or a walkout basement sort of deal. This is lower than the first floor. So that's 23 feet from the floor to the ceiling here, but 15 feet from the floor to the ceiling there. All right, sorry, a little bit sidetracked there, but let's get back to our drawing. So looking at what we've got here, looks like we know that this is 10 foot 3 from the floor to where this kind of L's out. So let's go ahead and draw in a line at 123 inches or 10 foot 3. We need to find out how far back this sticks out from here to here. Because I don't have that here, I can scale that too. Sometimes you have to. I would advise not scaling as much as you possibly can, because you're always going to run into some kind of rounding issue. Like you can see, I'm getting a constant like extra 16th of an inch for some reason. Not really sure why. But I'm going to say this is 1 foot 10. So we'll go 1 foot 10 here. Whoops, sorry. Okay, so 22 inches across it here. All right. And then from there to the ceiling, okay, we know that the ceiling is 23 feet tall from this floor up. So 23 feet times 12 is 276 inches. So overall ceiling height is going to run all the way up to here. Okay. All right. And then what we need to do is we need to find out the width of this panel here as well. Once we've done that, the only thing really left to do is to locate where the reveals are going on the drawing here. So we're at 1'3". Well, let's say 1'4". So 16 inches this way. All right. So this is kind of the general outline of our panels here. When we go to draw this at the end, we're going to detail out some of the other areas that aren't part of on-site scope. For instance, we do still need to show the glass, the base trim, and the glass up here, and the metal tracks. That, even though it's not part of our scope, it is going to be critical that we show it because it's going to allow the installers to be able to see what's happening around our panels here. If we don't show it, it really just makes it harder to locate where these panels go in the field and harder to understand what's happening around them. So we really need to show all the things that happen around our panels, whether or not they are part of on-site scope or not. So these glass panels here, we are going to draw them in later, but for right now, we are focusing on those panels and we will come back and add those in momentarily. All right. So at the very top of the panels, we know we have a 3/4 inch full depth reveal. So first things first, we're going to use the offset command. We're going to offset that line down 0.75 or 3/4 of an inch, just like that. And then we got to locate the other horizontal reveals in our panels here. Okay, so we kind of know that this panel reveal here is 10'3" from the floor to the top of that reveal. So what we're going to see is there should be a line continuing through here. And we discussed these being 1/4 inch spline reveals earlier on. So when we do that, we're going to offset this line 0.25 or 1/4 of an inch down. That way the reveal is in line with the bottom of the panel here and also the bottom of the glass window mullion over here. Since we do have that reveal located, we should be able to locate the center reveal here, this guy right here. And so what we're going to do is we are going to copy the 2 lines we have for that 1/4 inch reveal. And before I even select my base point, what I'm going to do is shift and right click my mouse. I'm going to go mid between 2 points. And I'm going to go between this point and this point here. Okay. Now, to be able to properly center this reveal, what you're going to do is hold down shift and right click once more. And you're going to go mid between 2 points once again. This time you're going to click on this endpoint here, which is the floor. And we are going to click on this point here, which is the bottom of our reveal above. To verify that that actually worked, it's not a bad idea to do a distance check. You can do that by typing DIST into your keyboard, and what it will do is give you a temporary dimension which will allow you to check and make sure that this panel from the bottom of that reveal to the top of this reveal, that's showing 61 1/4. You can see that in the distance right there. And if I go here and I measure from the bottom of that reveal to the floor, I should also have 61 1/4. So meaning that our panels are both equal in height. So we've actually completed that there. That's good to go. Let's move on to the reveals above, or reveal, I guess. There's only one there. We need to find out exactly how high up this reveal is compared to this one here. Now, something we can do is, because we do know where this mullion is and where the next mullion is, what we can do is we can kind of pull a dimension from this, holding down my shift key down to here. Looks like we're showing a distance of 8'3". Okay, so I know that's kind of a little bit long for panels. We might be able to make that work still, though. Let's go ahead and give it a shot. So let's draw a line off to the side, and we're going to go 8'3". 99 inches up from there to here. I'm going to trim that line back to there. Okay, and then I'm going to use the offset command once more to make this 1/4 inch reveal drop down here. Okay, so that should be the top of that reveal lining up with the bottom of this mullion. And this is kind of arbitrary because we are not given these reveal locations on the architecturals, but I'm basing it based on things that are located around our panels in the room. So kind of giving something or trying to line it up with something that exists within that room. Maybe not even the design intent of the architect, but it does make more sense to line it up with something than it would to not line it up with something. So I'm going to roll with that method of thinking. Again, if you wanted to confirm it, what you could do is either email or call the project manager, which is Rod Carrero in this case here, and just confirm that with him. You might have to issue what's called an RFI, or a request for information, to the architect to confirm that, or he might just be able to call and contact the contractor or the architect to confirm these reveal locations. All right, so these panels are pretty well established. We've gotten our reveals placed, we've gotten our panels drawn to the correct height and the correct width. We are going to move to the other side of the room, and we're going to work on these panels here. So for right now, what I'm going to do is draw them the way the elevation view shows. Because remember, before we talked about there's a discrepancy between the elevation view and the plan view here. Plan view shows the panels going all the way to the window wall from that 1 inch gap between the staircase wall and our panels. And then the elevation view shows this is a strip of material that goes all the way up. As unusual as that is, I'm thinking this might actually be more accurate because they are calling out other materials here like wall panel 3 and metal 1 and wall base 1. But let me check one more thing because there's a possibility. Oh, you know what okay, that's exactly what it is. So actually the plan view is more accurate. Sorry, not to flip-flop on you. But see where the elevation view is called out here, view 2 on A600? That elevation view is taken from here facing this way. So the problem is we are seeing this column blocking our panels. So going back to their elevation view, whoops, sorry. Their elevation view here, this is that circular column right here. It's hard to tell that's what's happening, but this column is in front of the panels. And so really when you think about it, these panels are going to actually go all the way back to here. You're just not seeing all of them because there's a column in the way right here. Okay, so that mystery is kind of solved. But we still need to find out what that width is from there to the window wall. We can do that here by scaling this view, or we could scale off of our plan view if we needed to. The elevation view is probably going to be a little more accurate, so we're going to give that a shot first and see what that comes back with. So let's go from here to the wall here. It looks like we have a panel width of 3'5", and that's even scaling to the nearest 16th. So, or setting our precision to the nearest 16th. So that's a pretty nice even number. I would say that's probably accurate. We're going to go with 41 inches there for that panel size. And again, just like we talked about before, the reveals are going to be located exactly the same as where they're located here. So when we go to draw these panels in, let's start by taking a line straight up just like this. So we are still at that, I think it was 23 feet tall. Width-wise, we're dealing with a panel width of 3'5" or 41 inches wide. So we're going to extend those panels this way and kind of trace these out. So again, thinking about it, I'm looking through the column here, so my panels do go from there to there, not stopping there at the side of that column. Confirmed by the plan view here, because you can see where that column starts and stops, and then that little sliver of that panel where you would see that there. Okay, so like we talked about, let's copy these reveals over from this side over to over here. We're going to use the extend command, and we're going to extend those lines so that they're touching the side of our panel here. Just like that. All right. And then the last thing we need to do is kind of detail these views out a little better. So right now we're dealing with this, which would be the panels over here, and this, which would be the panels over here. In the elevation view, it's going to be beneficial for our team to show everything that's happening around those panels. So let's go back to take a look at what we've got going on here. Okay, so let's start with the first view we began with. We have glass over here on this wall. We've got glass up here, and we've got these MTL5 channels that sit between the glass. All right, so we need to draw those in. Because that is scoped by others, we're not necessarily going to dimension any of that, but we do want to show it as accurately as we possibly can. And so what we're going to do is base all of our information off of what the architecturals are showing. So right now, they're showing these at 3 inches tall. That's 3 1/16, but we'll call it 3. And then this base trim down here, if we measure from there to the floor, is 6 inches tall. Okay, so let's start by drawing that in. Now remember, when you are drawing something that is by somebody else, you are going to want to use the existing layer to draw that in, not the geometry layer. So we're going to click on that, make that our current layer that we're using for our drawing. Then we're going to take some lines off to the side and draw them at some arbitrary distance here because we're going to trim them eventually anyway. So I just made that 50 inches long, and we're going to offset that line here, so 6 inches tall for that base trim. And then if you recall, we can either go from here to the center, showing that at 10 foot 4.5, or we can, well, let's do that because that's what they have dimensioned here. Okay, so we'll draw a line from the floor up here at 124.5 inches, or 10 foot 4.5. Okay, then we need to take a line straight across from there, and this is going to the center of that 3-inch mullion. And so with that being said, we need to use the offset command, and we're going to offset this 1.5, or half of 3 down and half of 3 up. Okay, and that does line up with that reveal. You can see that right there. It's perfect. Okay, and then we have another mullion at 8 foot 3 from the center of that one to the center of the next one. So we need to take a line from the center here, 8 foot 3 at 99 inches tall. We can copy these lines up using that base point of the middle there. And then we also need to copy these lines up to the very ceiling height up here. So just like that. Okay, kind of represents what's going on here in our view here. We do know that everything over here is glass by others. We got the base trim drawn in, we got the glass drawn in, so that's perfect. One thing that we also need to draw in is between the panel and the glass, there appears to be a vertical mullion here. that looks like it's, what are they saying, 1 and 11/16. So roughly, roughly about 1.5 inches wide shown. So I think that's what we're going to roll with there. Again, we're not going to dimension that because it is by others, but we do want to show that it is there. So in our drawing, what we're going to do is match what's going on here. We're going to take a line straight down here, just like that, and a line straight down just like that, and a line straight down just like that. It's kind of like stitching in all of these gray lines here. If you wanted to, let's say these blue lines and these gray lines are kind of overlapping. It makes it kind of hard to see what's happening. If you want to just see the gray lines, what you could do is highlight those. You don't have to highlight all of them, just one of them. Then you can go up to your layer properties up here, and you can see the stack of papers here called isolate. You click on that, it's going to isolate just the gray lines or the items that are on that layer. So now what I can do with that is offset those in, the 1.5, just like this. All right, and then what you can do to bring those back is if you click on the stack of papers right below that under layers, it will unisolate and bring everything back, just like this. Okay, so now we're seeing our panels, we're seeing the glass by others, we're seeing the base trim. So we're got a pretty decent amount of this view drawn in. I also want to investigate this a little bit further to see what's happening here. If there's a wall here or a doorway or what is happening right here. So we're going to go back to our plan view and kind of take a look at that and see what is the deal with this over here. See if it shows any information. And we're looking at these panels. This side here would be the side on the window wall. So we're looking at that side there. This side here looks like it's butting into a drywall wall. So it does look like there is drywall coming up, kicking back, and then running back up again, almost like a zigzag sort of deal. So when we go to put in the wall hatching, we're going to make sure that we draw it in just like that. All right, moving forward, one other thing that you'll want to drop in is a break line. So we do know when you use a break line, what you're doing is you're kind of showing, hey, this view continues, but I don't need to show all of it because it's not relevant to what I'm drawing. So what I just did there was I used the break line command. And when you use the break line command, it's going to ask you for 2 points, one being the start line of where you want the break line to be, the second being the end line of where you want the break line to stop. And then it's going to ask you one more point, which is going to be the center of the zigzag. If you don't click on anything and you just hit enter, it will place that zigzag right in the dead center of that break line. If you click somewhere on this line, it's going to place it right where your cursor is there. So I just hit enter there. It's going to put it right dead center. All right. Now break lines, we're going to go and put those on the dimension layer. So make sure that you are using the correct layer for that. That'll go on dimension. All right. And then we need to draw in the floor, wall, and ceiling hatch. And then this view is practically done until we get to the plot side of it later on. So to add in the floor, wall, and ceiling hatch, you can do two things. One, you can go into your tool palettes, go into hatching, and you can drag and drop a bunch of these in and kind of place them and sporadically make that wall hatch work. Something else you can do when you have complex shapes like this, which might be a little bit more beneficial for us in this case, is we can go P line or polyline, and we can trace out what's happening here. So kind of following the line of our panels here. And then the line of the ceiling. Okay, so I kind of just drew in this pattern here. What you can do with that then from there is you can use the offset command. And the wall hatch is actually 2 inches wide. If you were to actually measure it, that's what it comes out to. So now that I have that, I use the offset command, offset that zigzag line out 2 inches long. And then I'm going to isolate those 2 lines plus the break line here. So highlight all of those, go isolate. And then we're going to drag and drop the wall hatch in from our hatching tool palette. So wall hatch right here, walls and floors. Drag and drop that in, place it in there, and then delete the outermost line like that. Okay, and that's going to leave you with a very nice clean wall, floor, and ceiling hatch for your drawing here. So just like that, perfect. Okay, that elevation view is what I would call done, at least for right now. We're going to go over to here, and we're going to work on the next one. So this one over here, again, that's this wall right here, or this column here, behind this column here. Looking at the elevation view, find it again, I'm so sorry. Got a lot of drawings open. There it is. Okay, so looking at the elevation view for that, we have nothing up here. This is all open, but there is a wall back here and a ceiling and a floor. So we're going to need a wall, floor, and ceiling hatch for that. We're also going to have to show that there is a tile wall, TLO1, right here, as well as this wood wall cap, which is part of another drawing anyway, but we still want to show that it will exist there. This is part of T1. So when we get to labeling and plotting the drawing, we're going to actually point to that wall cap and say see T1 for wall cap reference. So for right now, what we're going to do is focus in on drawing these in. So, all right, let's talk about this first. So we know, looking at this, we can clearly scale some of this. We know that this is a 1-inch gap, and I can show you exactly where that came from. Let me save this real quick. There's a thunderstorm here. So if you're looking at the plan view over here, remember we looked at this blow-up view earlier today, A770, view number 1. You go to A770, view number 1, that is this view here, and then there's a blow-up on top of that, which is A771 here. Now, if we go to A771, you can see that's where the 1-inch gap lives. So it's right there. That's between our panel and the start of the wall cap for the staircase. So let's go back to the elevation view. That's what this double line is here, is that 1-inch gap. Offset 1 inch, just like that. And we're going to find out how wide this is from this line to the 1-inch gap. And make sure that you're using the correct scale on your architectural drawing set. So 3/8 equals a foot and 16th of an inch precision there. Okay, and we're going to go from here to there. And that's 2 foot 4 3/4 of an inch. Okay, so set 2 foot 4 3/4. That'd be 28.75. Okay, that's looking about right. Then we're going to go over here and we can measure a little bit further down. Looks like we have 2 foot 1 9/16, so about 2 foot 1 1/2, so 25.5 inches there before you hit the staircase. Whoops, come on, offset 25.5. All right. Then we got to get the height under control, because right now, kind of again, just like we talked about, we're drawing these as the existing layer because they are something that is provided by others. At least most of this, the wall cap will be by us, but it'll be in a different drawing. So to not call attention to it, I would suggest putting it on the existing layer as well. So that way it doesn't show up as a bold line, it'll show up as a grayed outline on your drawing. You want to show the height from floor to top of wall cap, if we can find out what that would be. One thing you can do is you could scale it, obviously. That would be one way to find out. Something else we can do too is from here, see if we can find a measurement on this. No, not quite. Not quite. About to say, because they do show you that wall cap here in the side elevation view going up those stairs, but you don't really get a height measurement on it. And so we may have to resort to just scaling it, which worst case scenario, that's what we got to do. It's not something we're going to dimension anyway, so it's really not super critical. But if we were drawing that T1 drawing, we want to make sure that that is 100% as accurate as possibly can be. So what I'm going to do is measure from the top of that wall cap to the floor and see what we're dealing with here. Okay, it looks like that's probably about 10'4" and 3/4, give or take a little bit. So let's go ahead and draw that in. So 124.75 be about there. And again, that's going from the floor to the top of that wall cap. And take a look and see if we can find a section view through the wall cap, because I guarantee you they have one here somewhere. Just so we can tell what this height is supposed to be, like what the actual dimension really should be there. So let's see if we can find that. Go back to our plan view here first, see what we can dig up. We got plan view A770, and does that give us a section view? We kind of have a section view here. View 1 on A771. Let's see what that comes up with. Okay, so maybe view 1 doesn't give us a dimension on it per se, but there's one over here that does. It looks like they're showing that cap at 1.5 inches with a 1-inch gap below. So we're going to match that here. 1.5 down, and then 1 inch from there to there. All right, now this wall cap, based on the elevation view, actually stops right there. It doesn't carry into that 1-inch gap, so we need to trim that back. Using the trim command, we're going to bring that back to there. All right, and then we can trim these lines back to here as well, because that doesn't go any further than that as far as the height goes. Okay. Let's see. Now, looking at this, you can see that this is looking at the wall cap. It's going on an angle up the staircase. So really, if you're looking at this, that would go away. And then the other thing we want to look at too is we need to see how tall from the floor to the top of this wall cap here would be. So again, we'll scale that and just check it out to see what we're dealing with here. So from top of this wall cap to the floor, looks like 3'11" and 3/16. It's kind of a weird dimension. Maybe they show that in their side views. Let's take a look. If not, we'll run with that. I just wanted to see if they showed it here at all. Nothing there. Let's see, what did this come out to? $28 3/4. Interesting. Okay, no big deal. I just wanted to see if it was dimensioned, and if it's not, that's okay too. We'll offset this up to 3'11" and 3/16. 47.1875. Okay, cool. Always helps to have a calculator at your desk. Even after years of practice, it's still good to make sure you got your math right there. Okay, so again, kind of like what we did up there, where we know this is an 1.5 inch thick top with a 1 inch reveal below. So we're going to show that just like this. Okay. So that kind of represents what's happening there. You might be able to trim some of these lines in a little bit here. Because you're probably going to have a 1x1 reveal under that cap. And again, we're not going to dimension it here. But later on when the cap gets drawn, we do want to make sure that it's drawn. So I'm just going to draw in a line at 1 inch tall and set it back 1 inch this way. All right. That kind of shows off that wall cap there. You kind of see what's happening at least. All right. So that covers that. Now, actually this base threw me off for a minute. There is no base over here. This is that other column that's in front of our panel. So really that doesn't matter. But we do probably want to show this glass up here. Although, again, it's not by us, but we're going to show it anyway. So we might as well try to draw it as accurately as we can. So kind of, again, scaling what we got here. Looks like a 1 inch setback there. And the glass is a total of, let's see, 1 1/4. So 12 1/4 tall. 1 and 12.25 tall. Cool. All right. Not too shabby. All right, so then that glass comes over to here. It's probably going to have another 1 inch setback from this edge. 1 1/4. I bet it's probably supposed to be 1 inch though. So we'll take this line across to here, move this in 1 inch, draw this line down from there, and we'll show the thickness of the glass here too, I suppose, that 1/2 inch thick. Okay, that kind of represents what's happening there a little bit. You kind of see the glass, the wall cap, the tile wall back here, and then of course our panels to the left of that. We need to draw in the wall, floor, and ceiling hatch. Now in this case we don't have a zigzag in it, so we really could just use the block for that over here. I'm going to drag and drop that in. Rotate this around. And we're going to place this in here just like this. Okay, I probably will throw a break line in here too. We don't really need to show the whole wall cap. We just need to show a little bit of it. So I'm going to drop in one more break line here. We'll go from the center of that wall cap up to here. Drop that in. Make this all the dimension layer for the break line. We're going to trim all the lines from that point on back to there. Okay, that goes away. These go away. And we can bring these lines back to there, just like that. Okay, now this may not look complete, but really this is all we really need to show. We got our walls, our ceiling, our floor. We've got the tile wall by others, the wall cap, which is by Onsite, but it's a different drawing. The glass here by others. And yeah, that's really about it. We got our reveals located, so that's good. What I'm going to do is move these elevation views over to our elevation view grid. And I think I'm going to take a small break, pause the video, upload this portion of it, and then we will go into the section views next, and I'll show you how to draw those. So here I'm going to save this where we're at, upload this portion of it, and then we'll move into the section views next.